everyone, welcome to Abhi online classes. Today we'll discuss some theorems in infinite series. First one, geometric series test. The series sigma r power n converges if 0 less than or equal to r less than 1 and it converges to 1 by 1 minus r. That means if r common ratio is less than 1, this sigma r power n geometric series converges. Suppose if r greater than or equal to 1, sigma r power n diverges. This is a geometric series test. Next one, auxiliary series test, which is also called P test. The infinite series sigma 1 by n power p equal to 1 by 1 power p plus 1 by 2 power p plus 1 by 3 power p and so on 1 by n power p and so on. This is an infinite series. This is convergent if p greater than 1. Suppose if p less than or equal to 1, this series is a divergent series. Third one, comparison test of first type. If sigma un and sigma vn are two series of positive terms such that there is a positive integer m and k belongs to r plus such that un less than or equal to k into vn for all n greater than or equal to m. If sigma vn is convergent, then sigma un is also convergent. That is, if sigma vn is convergent, then sigma un also converges. If sigma un and sigma vn are two series of positive terms such that there is a positive integer m and k belongs to r plus such that un greater than or equal to k into vn for all n greater than or equal to m. If sigma vn is divergent, then sigma un is also divergent series. If sigma vn is divergent, then sigma un also diverges. Next we are going to very important test, limit comparison test, which is very helpful for solving the problems. Limit comparison test. If sigma un and sigma vn are two series of positive terms and limit n tends to infinity, un by vn equal to L, that is not equal to 0, that should be finite and non-zero, then the series sigma un and sigma vn, they both converge together or both diverge together. Next test, comparison test of second type. Let sigma un and sigma vn be two series of positive terms if there exists m belongs to z plus such that un plus 1 by un less than vn plus 1 by vn for all n greater than or equal to m. First one, sigma un converges if sigma vn converges. If sigma vn converges, then sigma un also converges. Next one, if sigma un diverges, then sigma vn also diverges. If sigma un diverges, then sigma vn also diverges. This is the comparison test of second type. Now using the above tests, we solve one problem. Test for the convergence of the series whose nth term is sine 1 by n. Here we take nth term un is equal to sine 1 by n. As we all know, sin x expansion is x minus x cube by 3 factorial plus x power 5 by 5 factorial minus and so on. Using that formula, sin 1 by n equal to 1 by n minus 1 by 3 factorial into 1 by n cube plus 1 by 5 factorial into 1 by n power 5 minus and so on. We take 1 by n as common. 1 by n into 1 minus 1 by 3 factorial into n square plus 1 by 5 factorial into n power 4 minus and so on. We take Vn equal to 1 by n. Therefore, sigma Vn equal to sigma 1 by n. As we all know, this is an auxiliary series which is a divergent series. Since here P equal to 1, that is for P equal to 1, auxiliary series is a divergent series. Now we test limit n tends to infinity un by vn whether it is a finite and non-zero quantity or not. Therefore, limit n tends to infinity un by vn is equal to limit n tends to infinity un here is 1 by n into 1 minus 1 by 3 factorial n square plus 1 by 5 factorial n power 4 minus and so on by 1 by n. We cancel 1 by n. Limit n tends to infinity means 1 by n tends to 0, therefore this is equal to 0 and this is equal to 0. So on applying limit n tends to infinity, the only term here is 1, which is a finite and non-zero number. Therefore, by limit comparison test, the given series sigma un, sigma sine 1 by n also diverges. Since sigma vn diverges, sigma un also diverges. According to the limit comparison test, both the series either converges or diverges. So here, since sigma vn is a divergent series, therefore sigma un also diverges. Now we will see one more problem. Test for the convergence of the series sigma 1 by 2 power n plus 3 power n. Here nth term un is equal to 1 by 2 power n plus 3 power n. 1 by, take 3 power n as common. 1 plus 2 by 3 whole power n. Now we select Vn as 1 by 3 power n. Sigma Vn is equal to sigma 1 by 3 power n. We write this as sigma 1 by 3 whole power n. We know this is a geometric series and the common ratio is r equal to 1 by 3, which is less than 1, and therefore sigma Vn is a convergent series. So sigma Vn is a convergent series we got. Now we test limit n tends to infinity un by vn whether it is a finite and non-zero or not. Limit n tends to infinity un by vn. Limit n tends to infinity un here is 1 by 3 power n into 1 plus 2 by 3 whole power n by vn is 1 by 3 power n. Cancel 1 by 3 power n. Now limit n tends to infinity 1 by 1 plus 2 by 3 whole power n. We all know limit n tends to infinity x power n is 0 if x is less than 1. Here x is 2 by 3 and we also know this is less than 1. Therefore on applying the limit this is equal to 0. Therefore 1 by 1 plus 0 gives 1, which is a finite and non-zero quantity. Therefore by limit comparison test, sigma un is also a convergent series. Since sigma vn converge, therefore sigma un also converges. They both converge together. I hope you understood the above theorems and the problems which helps all the graduate and PG students. So thank you.